Okay, just recording a quick video here for U2L3 outside the boys' locker room because the dance room is always super noisy. So I hope nobody comes by yelling profanities. Okay, so U2L3. When we start talking about forces, it can get very confusing because they're all coming from different directions. So we draw what are called free body diagrams or FBDs. These label all the forces acting on an object and the directions of them. These are different though than we're not drawing vectors tip to tail. This is a different thing where we draw all the forces coming from the center of mass of the object, and I'll clarify that later in class. But FBDs allow us to determine the net force is that first blank. Sorry, I forgot to fill it in. Net force acting on an object, which is the sum of all forces that act on the object. Here's a little picture here that again, even if we have kind of a funky looking object, we address it looking at the center of mass, which in this case would be like right around here. The center of mass is the balance point. So even though there is a force, like the weight of this object is pushing down on the tray, the weight of this object is pushing down on the tray in those specific spots. Um, we can look at this as just where is the center of mass, and we can actually draw the forces coming from that center of mass. Don't get too confused about that right now. It really doesn't matter too much. It'll make more sense once you see an actual picture. So, other things to talk about here is lots of different types of forces. So, again, the Newton was named for Isaac Newton because he wrote a lot of laws about forces. We have lots of different types of forces, and just here's a couple examples. These are the main ones we're going to get to in this class. Honestly, though, besides drag force and buoyancy, actually, we don't really get to, but just there's lots of different types of forces. These are going to be the main ones we're going to talk about. So I was going to have you watch this video and take notes, but I can talk through them very briefly. In the same way that this video was going to. So, an applied force is just going to be a push or a pull. I have a stylus. I forget my computer has a stylus, so I can write this. An applied force is a push or a pull. Yeah. This is subscript. Usually we just write F for this, or we can put FA for applied force. Yes. And that's like a direct contact type thing. Yes. It's just like usually if it's just somebody who's pushing or pulling, we call it an applied force. Just some outside force, not anything like special. Gravitational force is special, right? Because gravitational force, we don't see it, but it just acts on us, right? So gravitational force we label as Fg, right? And we know the gravitational force always pulls in which direction? Downwards. Now, you got to be careful though. This is the acceleration due to gravity, right? When we say, oh, gravity is 10, that's not the force of gravity. The gravitational force, well, if F equals ma, right? Well, then the gravitational force is mg, which is your mass, whatever your mass is, times 10 times the gravity, right? So do not get confused between the force of gravity and the acceleration due to gravity. Those are very different things. And again, we'll continue to clarify that in class. The normal force, so this is a new force you might not know about, but we're going to talk about a lot more in class. Now, the normal force is whenever I have a surface on a surface. If there's no surface, there's no normal force. But if I have an object here on a surface, what happens is the normal force is the surface pushing up against the object, yeah? And we label the normal force Fn. It's always perpendicular to the surface, and again, we're going to clarify that a lot later. But this is the whole reason why you don't sink through objects, right? The surface you're sitting on, the surface I'm sitting on right now is pushing up against me, and that's why I don't sink down through it. Yeah. So the normal force is always perpendicular to the surface itself, and we'll talk about that more later. Okay, friction force. So you will see friction force a couple different ways. Friction force is F for friction force. However, we're going to learn there's actually two different types of friction forces. There is static friction, so Fs for static friction, or Fk for kinetic friction. And the frictional force always acts opposite the direction of motion. So opposite motion. No matter what, the friction force slows something down, right? As a rule, friction slows things down. So if I have an object that is traveling this way a distance, the friction force is always going to act opposite the direction as a rule. Lastly, the last kind of big force we're going to talk about is tension force. So, tension force is like an applied force, but it's specifically from a cord or a rope or cable, whatever. If I tie a string to something and I pull it, yes, the tension force is what we call the force from that cable. So, once again, if I have a string here attached to a ball, it's pulling the ball upwards. We would call that FT for force tension. Yeah. Again, tension force is technically an applied force, but there's different things we can do with it because strings can only handle so much tension and then they can snap. So we can address them a little bit differently than just a normal like applied force. So one last slide about making an FBD, and then we are going to finish this up tomorrow. So in making an FBD, let's go ahead and you need to keep it clean and simple and label all vectors. Even if you're talking about something complicated like forces acting on a person, don't draw a person. We actually use a dot or sometimes a box, you'll see me do every now and then, or a box to represent the object. Because again, we care about the center of mass, right? So even if I have forces acting on me, we only care about the center of my mass and the forces acting on that. And so that's a dot, the center of mass. We use arrows to represent forces, but this is different than again, this whole tip to tail concept. All tails touch the dot. So if I have, here's my object, if here's my object, I might have a force here, I might have a force here, I might have a force here. All my tails touch the object, right? These are all the tips here. So this is different than drawing vectors tip to tail to add them. This is trying to visualize what's going on here, yeah, and this is how we can visualize it. You only include forces acting on the object, not forces the object exerts. So we're going to learn this later. This is Newton's third law. But if I am, let's look at this wall here. If I am pressing on this wall, yeah, the wall actually presses back at me. But if I am drawing an FBD of the forces acting on me, yeah, I would only draw the force of the wall pushing back towards me. I wouldn't draw the force that I am exerting. That's not what an FBD is for. Only forces that are acting on me. So right now, gravity is acting on me. The normal force is acting on me as well. We're going to talk all about that in class. Not any forces that I exert. We can add congruency marks to show when two vectors are equal to each other because that's going to happen very often. We should know congruency marks from geometry, right? That would be like those two are congruent, even if I didn't draw them very congruent. They're the same length, yeah. Do not draw X and Y components on an FBD. So on the AP test, they might say on an FRQ, draw an FBD. Or they might say on a multiple choice, what's the correct FBD for the situation? Don't put any XY components on them. We'll add them later to solve the problem, but if literally they're just asking for an FBD, don't put any XY components. Meaning, like, if it's an angled vector, don't also draw the X and the Y. So here's an example of a free body diagram. If there is a block resting on a table, so this is like my block, right? We have the normal force pointing up, exerted by the table. We have gravity pulling it down. If I'm pushing this is pushing up against a block on a table. This is the force of friction and the force of the wind on the block. Again, we're going to talk a lot more about all of this later, but the big thing I want you to notice is that we are drawing all of them coming from the center of the dot. We're not drawing them tip to tail. Okay, so tomorrow we are going to continue practicing drawing FBDs so that we can visualize how these forces act on objects.